Okay, the last thing that we're going to talk about in our energy and force unit is what is a force and how a force is classified. So this is learning target 13. Describe how a force can affect matter and can also start energy transformations. So remember the example I gave you in the last section of notes where in order for a ball to roll down the hill, a man had to apply a force to push the ball. So that force is what started that energy transformation. So, reminder, matter is anything that has mass and takes up space. Motion of matter can be affected by forces. So how matter moves can be affected by forces. Again, you have to have a force to push that ball to get it to move, to get that potential energy to be converted into kinetic energy. A force is a push or a pull. It's not matter or energy, however it affects both. The units for measuring a force is newtons or N, because Sir Isaac Newton was the one who discovered what a force was or is. Okay, there's two types of forces, either balanced or unbalanced forces. A balanced force, there's no motion, no movement. And that means forces are equal and in opposite directions. I'm going to give you some examples in just a minute. An unbalanced force means there is motion, so matter is moving. Forces are unequal in opposite directions. So let's take a look at this. A balanced force. If equal forces act on an object from opposite sides, the object doesn't move. So you've got these two people both pushing on this, let's just say it's a door, I don't know, and they're pushing with equal forces, same amount of force, in opposite directions, so the object doesn't move. It's kind of like when you play tug of war. If both sides pull the same amount of force, the flag in the middle does not move. That's considered a balanced force. Now, unbalanced forces are unequal forces that act on an object from opposite sides and they make the object move. So in this case, the guy on the left has a larger force than the guy on the right, so they're unequal forces and the object's going to move to the right. So those are the two types of forces, either balanced or unbalanced forces. So if an object is not moving, there's usually balanced forces acting on the object. If an object is in motion, then you have unbalanced forces. So think of it this way. If an object contains potential energy and is not moving, then that also means that there are balanced forces acting on it. So that's how forces can affect energy. So now let's look at types of forces. So types of forces. Gravity is a force that exists between any object with mass. The gravity will decrease as distance between objects increase. This is called an indirect relationship. So if you take a look at this picture right here, okay, the farther away a planet is from the sun, okay, the less gravitational pull there is. So planets that are farther away, like Saturn and Uranus and Neptune, they are farther from the sun than Earth is. So they don't have as strong a gravitational pull as Earth to the sun does. This is called an indirect relationship. So if one goes up, the other one goes down. So if force decreases, it goes down. As the distance between an object increases, it goes up. That's called an indirect relationship between two characteristics. Okay, so here's a little comic that goes with that. Sir Isaac Newton discovers a talking apple. Do you realize the gravity of this situation? That's how Sir Isaac Newton discovered a force in gravity. So it's kind of a cute little graphic. Okay, weight is a force that depends on mass and the gravitational pull. So weight is mass times, and I forgot my Y on gravity, gravity. Here on Earth, The gravitational pull on Earth is 9.8 meters per second squared. That's in terms of acceleration. So if you want your weight, when you step on a scale, it takes your mass and it multiplies it by 9.8 meters per second squared. And that's how we get our weight. Weight can change when you go to space, because when you go to a different planet or even a moon like our moon, the force of gravity is what changes. So your mass never changes. That's one of the differences between mass and weight. Mass never changes, but gravity does. So if you look at this example right here, if we go from the Earth has 9.8 meters per second squared force of gravity. If we go to the moon has a smaller mass than the Earth. That means if you have a smaller mass, then you have a smaller gravitational pull. That's why the moon revolves around the Earth and not the other way around. So if we were to travel to the moon, we still have the same amount of matter, still the same mass, but our weight would change because on the moon the force of gravity is less. So we would actually weigh less on the moon than we do on Earth because gravity changes. If we go to a planet like Jupiter, which is bigger than Earth, it's going to have a higher force of gravity. We'd weigh more. So weight is considered a force. Friction, I mentioned that in our last section of notes. It's a force that opposes motion. It brings, and no, Miss Stevens has got some misspelling. It brings an object to a stop. In order for friction to occur, objects must have contact. So the example we did on our last section of notes was when a roller coaster was going down a track, the wheels going against the track, there's a force of friction. That's what changes some of that potential energy to heat, and it doesn't all get converted into kinetic energy. So that's another way that forces affect energy. Friction will cause some of that potential energy to always be converted into heat energy if there is contact. A contact force is a force that exists between objects that are touching. So anytime objects are touching, there's a contact force. So an apple on a desk, the reason why the apple is not moving is because there's a contact force between the apple sitting on the desk. Air resistance is another force that opposes motion of a falling object. So the force of gravity always pulls things down. Air resistance goes against the force of gravity, because when something falls, air molecules are hitting whatever's falling, and that's pushing up on the object, whereas gravity is pulling down. So those are some examples of forces that act on objects, and it's going to cause objects to change their motion. It's also going to cause energy to be converted or not converted. So that is how forces affect matter and affect energy transformations.